we've now calibrated the eyepiece Graticule. We're now going to use this to find out how big cells are. So we start with an animal cell. If you remember, we always look at this, draw the cells using the blue 40 times lens. So I'm going to quickly focus this, clip it in the microscope, move it round. Okay, you can see I'm using the normal lens, so just one eye. Okay, focus it with the blue lens, so we've got total magnification of 400 times. Okay, so I'm now going to go to the eyepiece Graticule. I'm going to rotate it and move the slide around a little bit so if you like, the ruler mark is going across one cell. Now, here's a photograph I took a minute ago. I just make it a little bit bigger. So you can move the slide around, but if you notice, I've got this pink slide here. And I've lined it up so it's going from 40 to 66. So that's basically 26 eyepiece divisions. Okay, 26 eyepiece divisions from there to there. So let's just go and do the calculation now. 26 eyepiece divisions. We know from the calibration now that one eyepiece division at 40 times magnification is 2.6. So the length of this cell is 26 divisions times 2.6, and that equals 67.6 micrometers. Now when you do the experiment for yourself, I'll actually get you to measure 5 different cells. You move the slide around, rotate the eyepiece Graticule, and then you'll get the average size of the cell. Okay, but you can see that's 67.6 micrometers. That would also, you could say that would be 0.067 millimeters. Now we're also going to look at bacteria cell and do the same. So I've got the same sort of cells. So I can go back to the red lens again, clip the slide in. That's already in focus. That's good. Okay, a drop of oil, and then I'm going to move the white 100 times objective lens in, focus that. Once I can see individual cells, I'm going to move the Graticule around and line it up against one cell, and it can help sometimes just to move it slightly so you're lining up a cell right on the line. Okay, now here's one I took earlier. Now, I know that there's 2 cells there, end to end, and it's going 1, 2, 3, 4, 5 divisions for those 2 cells. So it's like 2.5 divisions per cell. If you look at this one here, again it's like 2 divisions for that cell. So if you go these 2 here, I know it looks like 1, but it's actually 2 cells end to end. That's basically 2.5 little divisions per cell. So let's quickly do the calculation. We know that 1 division now for my calibration is 1 micrometer. So, simple calculation this time. 2.5 divisions per cell times 1. We know the bacteria cell is 2.5 micrometers. And again, when you do this, I'll get you to measure 5 different bacteria cells and get the average. And you can quite clearly see here, this animal cell is more than 20 times longer than a bacteria cell.